A, B, and... Oh, just kidding. D is not a quadratic either. May? The highest x power is a square, correct. So the highest exponent on x is a 2. In other words, x squared. So I put C and D in this section because we can still solve them by the zero product law, but they're not technically quadratics, because what's their highest exponent on the x? 3. So these are actually cubic, because they have x cubed as their highest exponent. But the way we're going to solve it is going to be the same. And you're going to hear a ton of times this year me asking you to identify what type of equation are we dealing with. And you need to be able to say if it's quadratic or cubic or many of the other ones that we will eventually get to. But whether it's quadratic or cubic or a highest power of 4 or a highest power of 5, they all start the same, which is get them equal to 0. So step 1 is get equal to 0. So on part A, we can either take the 2 terms from the right and move them over to the left, or take the 3 terms from the left and move them over to the right. I would think it would be more efficient to move the 2 terms, right? And by move them, I'm not just saying pick them up and drop them on the other side. I'm saying mathematically, doing it in a mathematically correct way. If we want to get rid of negative 2x on the right side, we have to add 2x to both sides. Again, that whole concept of as long as we add the same thing or do the same thing to both sides of the equation still have to be equal. I want to get rid of this plus 10, so I'm going to subtract 10, and I'm going to do it to both sides so that the two sides remain equal. So with that, we have x squared plus 5x minus 24 equals 0. And then step 2, when you're solving quadratics, could really be, there's like multiple ways of solving quadratics, but with the zero product law, you're definitely solving by factoring. So step 2 is going to be factor. And with a quick guess and check, who can tell me what this factors into, Evan? X plus 8, x minus 3. Very good. And then because we are solving, keyword solve, that is our indication to tee it up. So we set x plus 8 equal to 0 and solve quickly. Get x equals negative 8. Set the next factor equal to 0 and solve. And we get x equals 3. Now you've done all this before, yes? This is just a review. Okay? Jump down to exercise C then. Because a cubic I don't believe you've done. Is that fair? But we're still going to get it equal to 0. So usually we prefer the highest exponent term to remain positive. So I'm going to subtract 3x over. And I get 3x cubed minus 3x equals 0. Yes? And when I factor, now here's where our kind of better factoring skills are going to come to use. How do I start factoring this, Grace? Okay, well, backing up, if this is the expression that I'm factoring, I've covered up everything else. What's the first step to any factoring problem? Find the GCF, and what is it? 3x. So we're going to take out 3x and aid in what's left. X squared Plus or minus? Minus 1. Perfect. Is that factored completely? What do you think? Can either of those factors be factored further? Micah? Which one? Because it is the difference of perfect squares. So this x squared minus 1 is going to factor into, what's the vocab word, Kaylee McCadden? Going to factor into, what's the vocab word? Starts with a C, ends with conjugates. Conjugates. You never remember that. Good job. So the conjugates here are x plus 1 and x minus 1. And then we tee it up. So get equal to 0, factor, and step 3 is to tee it up when it says to solve. And it does. So when we set our, now your t is a little bit bigger, right? Tee it up doesn't even really work anymore because it's not a t. But we get the idea. So if we set 3x equal to 0, and we solve that by dividing by 3 on both sides, what's our answer? 0. When we tee x plus 1 up, subtract 1 from both sides, we get x equals negative 1. And when we tee the third factor up, add 1 to both sides, we get x equals 1. So we have how many solutions? 3, right? 0, negative 1, and 1. Solutions, just like solutions have always been, they're values for the variable that would make the original equation true. Can we all go back and see that if I plug in 0 and check it, what would my left side be if I plugged in 0? 0. What would my right side be if I plugged in 0? So 0 equals 0, that checks out. What if I plugged in negative 1? What would the value of my left-hand side be? What's negative 1 cubed? Negative 1 times 3. So that would be negative 3 if I plugged in negative 1. What if I plugged in negative 1 to the right? So I'd have negative 3 equals negative 3. That checks out. Also, if I plug in 1, what is the value of my left-hand side? 3. If I plug in 1 to the right? 3. So they all work. There are 3 solutions. Why did this one only have 2 solutions, but now this one has 3 solutions? Correct. It's because of the type of function that it is. Quadratics, because it has a highest degree of 2, usually have 2 solutions. Not always, but at most 2 solutions. And when you're cubic, you have at most, not always, but a lot of times you'll have 3 solutions, right? What if the exponent was 4? How many solutions could you maybe expect? 4. Do we get all that? Okay, because something to the 4th power usually factors into 4 pieces, and each of those pieces produces a solution. Again, not always, but that's the maximum number of solutions that you would ever have. Okay? We've all seen quadratics that have 1 solution. We've all seen quadratics that have no solutions. Okay, it's been a while, but we will review all that. Flip over to the back. We'll come back to those other 2 examples on the front if we have time. Okay, here is a system of equations. Like I promised, systems are going to come up as we move through the year. And this one we have, what type of function is that? Quadratic with the x squared. What type of function is this? Line. Linear. Perfect. Find the intersection points of these curves algebraically. Now, algebraically means obviously you have to do it by hand, and we have 2 methods, right? Substitution or elimination. Elimination, we're really going to reserve fully and completely for those 3 variable systems, x, y's, and z's, that we worked on already. Any other system is pretty much going to be done algebraically, which means get some variable all by itself, and we're lucky enough we have 2 variables already by themselves. So we'll use this. Y equals 4x plus 5. Because y equals 4x plus 5, I can plug that in for the y in the other equation. So that will read, when I plug it in, 4x plus 5 equals 3x squared minus 8x plus 5. And now I am solving just a quadratic equation like on the other side. So step 1, get it equal to 0. I'll subtract my 4x over, and I'll subtract my 5 over. So it's equal to 0. And would you look at that, my plus 5 minus 5 canceled, so this is nice. Makes factoring a little bit easier, because now it's only 2 terms. So if I look for a GCF, do you see one, Cameron? 3x, and what's left when I take out a 3x? Minus 4. And then I tee it up. So if 3x equals 0 and I divide by 3, I get an x equals 0. If I tee up the x minus 4, what's my solution? X equals 4. Now, this was a system from the start. There are 2 variables in each of these equations, which means there are 2 variables I need to solve for. I just got the 2 possible x values. So here's what just happened. I got 0 as an x coordinate. I don't know what the y coordinate is yet that goes along with that. I also got 4 as an x coordinate. I don't know what the y coordinate is that goes along with that. But just like any other system, once I have one variable's value, I can plug it into either original equation. I'll plug it into the linear because that's just easier. So if I know x is 0, that gives me y equals 4 times 0 plus 5. And so what does that y equal? 5. So that plugs up my missing coordinate there. And if I know an x coordinate of 4, I can do the same thing just by plugging in the x coordinate of 4. And what's my y coordinate there? 21. Have you ever done systems like this before? Probably not a lot of them. Algebra 2 might expose you to it once or twice, but it's not really a skill. You all do like just linear and linear. Now I'm doing a quadratic and a linear, so they cross twice. Now on my calculator, part B says to sketch a graph of this system. So the first equation is y equals 3x squared minus 8x plus 5. The second equation is 4x plus 5. And just so we're all on the same page, I'm going to do zoom 6 to get it from negative 10 to 10. There's my quadratic. There's my line. Now, when you're solving a system, you're pulling where the graphs cross. We all know that, right? Okay? So we see the parabola part of it, and we see the line, and we see one place where they cross. If you did second trace intersect on your calculator, which solution is that one? Is that the 0,5 or is that the 421? That's the 0,5. I don't see the 421 because I only went up to 10. But if I change my window, I'll see that it's going to cross again. Can we all make sense of that? Okay, if I change my window and I go instead to like 30, there's my parabola. Here comes my line. There's the 0,5 crossing point. There's the 421. So second trace intersect will give you this one. Second trace intersect again will give you that one. I want you to sketch a graph of this really quickly so that we remember that our solutions of a system are where they cross. Excuse my squiggly parabola. So this one was 0,5 and this one is going to be 421. Does that make sense? Okay? And the last thing with parabolas and graphs of them, for today. We'll do a whole lot more. They're showing you a parabola, right? So if you look at the graph, part A says, what are the coordinates of the x-intercepts? So where is this graph? At what numbers is this graph crossing the x-axis? Right here, which is at what number? -1. And right here, which is at +3. Okay? This is a flashcard question. If we have to do it algebraically, not graphically, we just did it graphically up here. If you had to do it algebraically, how do you find an x-intercept? What does the back of that flashcard say? Set y equal to 0. So we would take our equation, we would set y equal to 0, and we would solve. This one, guessing and checking, factoring, would give you those two factors. And when you continue to solve it and tee it up, we're going to get x equals 3 and x equals -1. So all the while when we were solving on the front, those are the x-intercepts of that function. Same thing with cubic, by the way, and we'll get to these kinds of graphs. Those are the x-intercepts of that function. Does that make sense? So when you see find the x-intercepts, or you see find the zeros, or you see there's one more word, you see find the roots, that all just means solve. Because your solutions are the x-intercepts. Your solutions are the roots. Your solutions are the zeros. All those words mean the same thing. Is that clear? So since we're finding the x-intercepts in this section, we would set y equal to 0 and solve. And that would give us those roots, or those zeros, or those x-intercepts. Whatever you want to call them. In the exam, we'll use all of those words interchangeably. Roots, zeros, x-intercepts. So know that all means the same thing. There's your homework. Thursday. Do they do that anymore?